the Cloud OnAir, live webinars from Google Cloud. We host these webinars every Tuesday. And my name is Chris Kleban, and today I'll be talking about cloud GPUs. You could ask questions anytime on the platform, and we have Googlers standing by to answer them. So let's get started. So if you're on the audience, live or watching the recording, let me just spend a couple of minutes talking about what a GPU is in case you don't know. So as this picture shows, GPUs started with gaming. My mom would play Frogger back when I was a little baby, trying to get that frog across the road or over the river. I played Nintendo, Super Mario Brothers, going down the pipes in the secret warps. And my son now plays Minecraft on his Xbox with his friends. And over the time of these generations of gaming in my family, the graphics have gotten better and better. And those graphics have gotten better thanks to a little hardware chip called the GPU. These GPUs are everywhere. They're in your cell phones, in your laptops, in your game consoles, in your PCs, under your desk. And for data centers and cloud, what we do is we take that small GPU and make a really big one. And that big GPU, you'll see a picture of 3 of them stacked on one on top of the other. We put them in servers, and like GPUs do for gaming, GPUs in the data center do for computing. Gaming needs lots of things drawn on the screen in real time. Scientific research needs lots of math done as fast and as quickly as possible. So how does GPU acceleration compute work? Well, you take some application code. It could be written in Python, C++, TensorFlow, anything you want. And all that code mostly runs on the CPU. The CPU does things sequentially, right? One after the time. There's some if-then logic. But what if your application code has a bunch of math it wants to do? Instead of doing it one at a time and taking a long time, what if you do that math all at the same time? So the code in the green, the math part, let's ship that to the GPU that could do it fast. Let's multiply 10 numbers together, 100, 1,000,000, 1,000,000,000, get it done quickly, put the results back to the CPU. And in essence, that's GPU accelerated compute. Together, it's speeding up your applications. So what kind of workloads are we talking about here? The first one's machine learning, right? GPUs are all about machine learning and AI these days. And there's 2 types of workloads, training and inference. Training is about building the artificial intelligence logic, birthing it, if you will, right? It's not a person saying, well, if the car sees a human, you better hit the brakes, you better turn left, you better turn right. It's not about that at all. It's about putting a bunch of data, synthetic or actual, through some logic, having the computer system learn what the right behaviors are, or learn how to define a cat in a photo, right? And build that AI intelligence. And then machine learning inference is once you have that intelligence, it's doing something with it. Right? Google Photos is this great app, for example, and it does searching. Right? I have 100,000 pictures of my kids, right? But it's really hard to find the picture that I'm looking for. Well, in Google Photos, I could just click the picture of my son, Aiden, type in the word beach, and now it predicts and finds really quickly with accelerated hardware all the pictures I'm looking for. And a user doesn't want to wait 5 minutes, 10 minutes to find that. They want it automatically. And that's what inference is, using the AI to do something. GPU acceleration is also great for HPC, right? Or high performance computing workloads. Here we're talking about weather simulations, engineering, seismic analysis, a bunch of things that typically run on grid systems. And then there's the classic visualization case. It could be gaming, or it could be a working professional that might have a workstation under their desk with expensive GPU hardware, right? And maybe the cloud GPU is the better approach there. So those are a few workloads done by GPUs. So let's talk about one of the first 99 problems, but a cloud GPU ain't one. The first problem is about access to compute power. So if we asked a bunch of AI researchers and experts, what are the things that contribute to all the AI advances? 80% of them said one of the main reasons was just access to raw, high-power compute. It's amazing, right? It's not necessarily that we're learning to do new things. It's just access to more power that's really driving things forward. On the other hand, we asked people coming to TensorFlow organization, which is an open source machine learning algorithm creation framework. We asked them, what are the problems you have with building AI? And a large majority of them said, well, we just don't have access to the compute we need. So here we have this problem. Access to compute drives innovation. People trying to innovate don't have access to compute. So there has to be a better way. So according to an article on time.com, if you wanted to buy a supercomputer, right, one of the largest computers in the world, it might cost you $100 million or $250 million. That's a lot of money. On the top 500 list, which lists the biggest supercomputers in the world, back in 2008, the #1 supercomputer had 1,456 teraflops. That's a lot of power. But imagine if you're a researcher working on a really important business problem, like I want to get some recommendations for online shopping, or I want to innovate with self-driving cars. And let's say you went to your CTO or your director and said, can I please buy a supercomputer for $100 million? Right? You would be laughed at. Not because the business problem isn't real, just spending that capital up front is crazy. So let's talk about the alternative. Let's say we take 1,000 K80 GPUs on Google Cloud and create a cluster for an hour. Using regular on-demand pricing, it would cost you about $500 for those 1,000 GPUs to run an experiment to see if what you're working on will do the thing you need for your business. And if you use something called preemptible GPUs, which we'll talk about later, you could even drive down that cost even more to $250 an hour or less. So now let's say you have that same conversation with your IT director who manages the budget and say, I want to solve this really important business problem. I want to do some quick innovation tests to see if this is going to work. Do you mind if I spin up this cluster, a supercompute worth of power, spend $250? Well, you'll be laughed out again, but not because they're going to say no. They're going to say, of course, just go do that. So that's the power of Google Cloud, right? Bringing new scale of compute. And let's go ahead and show you a demo of what it looks like to spin up a cluster of compute instances. So what I'm showing you now, this is the Google Cloud console. Google Cloud, if you go over to the top left, you'll see there's a lot of services here. There's VM instances, instance groups, and what we're in the compute engine. This is all about infrastructure as a service. And what I'll show you is how to do an instance group. And what an instance group is a logical entity of infrastructure. It could be one server, it could be 1,000, it could be 10,000, and you use those instance groups to run a series of workloads, right? You can scale it up, scale it down. You could have Google auto-scale it based on load. So to create an instance group, click on a button, give it a name. We're going to call this Cloud OnAir 5. We are going to pick a single zone because we only care about doing this experiment. We're going to pick a region. Plenty of regions to choose from. We'll pick Asia East 1, Asia East 1A as a zone. And there's two kinds of instance groups, managed instance group and an unmanaged instance group. The managed instance group we could do a lot of things for. We could do rolling updates, roll your code forward, roll it back. We could do auto-scaling, load balancing. And for this demo, we'll pick this. For instance templates, right, this is where you go ahead and pick a template to create a virtual machine. And here you're going to pick the size of the VM, the shape, and all of that. So we're going to go ahead and customize an instance template. We'll pick the number of CPUs we want, anywhere from 1 to 96. We'll pick the amount of memory we want, and we'll go look at GPUs. In this case, we want 1 GPU per VM. And since this is a demo, let's just do 1 core. And let's do 4 gigabytes of RAM. Let's do 1 GPU. Let's give it an operating system. Here, there's plenty to choose from. Application images, OS images, custom images, right? In this case, we'll just pick Ubuntu with a standard disk or an SSD disk. Maybe this is machine learning, so we want to go fast, and we'll pick a 10 gigabyte SSD back disk. We'll save this image or this template called instance template 1. So now that we have this template, all we need to do is create 1,000 copies of this. So we'll go down to auto scaling. We'll turn this off because we want to create a static cluster. And for this demo, we'll just put number of instances as 1 for now. And we'll hit create. So now Google Cloud's creating this logical group in Asia with 1 VM. It's going to give each of those VMs an IP address, an SSH key. It's going to secure it in your own private network. It's going to have NVIDIA drivers installed with CUDA. Depending on your application, you can go ahead and pre-install your application like TensorFlow or whatever you need. If you click on the logic group, you'll see that there's 1 instance installed. It has an IP address, an external. You can go over to the Details tab and look at what kind of instance template was used, whether or not auto scaling was on. You can go over to monitoring to see things like how much CPU utilization your cluster is using, or the size of the cluster over time, and so on and so forth. If you go to the instance, you can go in and SSH to the instance that was just created. And since we want a supercomputer, right, we want 1,000 VMs all at once. We want to run that experiment really quickly, super compute power, right? We don't want 1, right? We want 1,000. So I'm going to change the number of instances to 1,000, and I'm going to hit save. And now what Google Cloud's going to do, it's going to spin up, and it's going to create 1,000 instances. All of them with the infrastructure I need, the applications installed, and I'm going to be able to use that for my workloads. It's going to take a few minutes, and for the sake of time, we'll keep going. But just like that, you get a supercomputer in a matter of minutes for an affordable price. So let's switch back. So we talked a little bit about scale. We talked about GPUs, why they're important. Now let's double click on AI a little bit. Businesses no longer have the option just to skip artificial intelligence and machine learning, right? It's innovate or die. How can I differentiate myself from the competitors? How can I reduce costs? How can I do something new? How can I disrupt an industry? So these are things that are happening now, and every organization around the world is starting to think about it and implementing it. And who better to partner with on artificial intelligence than Google? Google has been an AI company from birth. Google Search is well known for giving the best results. Waymo, self-driving cars, we're working on that technology to bring that to the masses. I've already talked about Google Photos and how that uses AI. And I particularly also love YouTube, right? My kids will borrow my phone, use YouTube all the time. And now when I pick up YouTube, I get recommendations for things like, do you want to see Daniel Tiger? You know, I don't, but I know my kids do. And we built in these artificial intelligence features into our products. The blue graph that you're seeing on the page, this is showing you the number of projects internal at Google that have the Google Brain AI model built into them. As you can see, exponential growth with the number of things internally that we're doing with artificial intelligence. But why partner with Google on ML, right, with GPUs and otherwise? We already talked about scale. We talked about how easy it is to go get yourself a supercomputer. We talked about speed and why GPUs are really important, right? It's about doing your compute faster. If you do what you need to do on CPUs, it's going to take you a really long time for these workloads, and you don't want to wait. So why not offload to GPUs? We showed you the K80, which is a few generations old GPU by now. But we also have the P100 and the V100, newer generations that are faster if you want ultra high performance. And we've also come out with a cloud TPU. This is an ASIC, or a little chip, just like a GPU, but it's specific for machine learning. So if you're running in TensorFlow, you could write ML code on CPU, GPU, or TPU, and if you pick Google Cloud, you can be rest assured that we'll always have the fastest infrastructure for you, regardless of whatever you want to choose. So if you don't want to deal with infrastructure, we also have a suite of services in AI. Let's talk about the quality of our AI models. If you're just a programmer running in Python or building web apps and you don't want to worry about doing your own HPC or ML clusters, we have AI services packed by APIs. Google image recognition, translation, video analysis, all of these that are just an API call away do a prediction for you with super high quality. Or maybe you do want a custom ML model. We have a brand new service called AutoML, and I really love this. This is machine learning creating machine learning. One of our customers, Disney, They came and they said, we have these Disney products, and we want our customers to be able to search online for the right product. And we want to use Google expertise to build this image recognition system. Can you please use AutoML to do it? And they have very smart programmers. They came in, they picked up our API service, created a machine learning custom model just for them very quickly, and were able to launch that into their shopping experience. So machine learning at Google Cloud, it's a bunch of things all together. On the bottom layer, we already talked about hardware accelerators like GPU and TPUs and why they make it faster and how you could save time and money by using them. But it's also, as the left shows, about the data. We have very large object storage where you can put in your raw files. We have BigQuery for databases and analytics. We have Dataproc, which does Hadoop and Spark clusters for HPC-style workloads. But then there's also up the stack from the hardware. We have the Kubernetes engine, right? This is a cluster of servers that run containers, first class. And GPUs are integrated into our Kubernetes engine, where you can go ahead and run your HPC and ML workloads on a Kubernetes cluster with containers. Or let's say you don't want to deal with the infrastructure, containers or VMs. We have Cloud ML engine, also powered by GPUs. Cloud ML engine is you want to do some training or inference ML workloads, but you don't want to create the infrastructure. So you just deal with our APIs or UI or G-Cloud, and you say, I would like to do a TensorFlow job and train a model. Please give me the results and use this data. Or I would like to do predictions and inference workloads with the model I just trained. Right? But it's a managed service and abstracts that complexity away from you. We also have Kaggle, which is a great community of ML experts. Right? And they also do competitions for ML. I myself did a competition, right, in Kaggle, and I learned all about how to code and use TensorFlow. It was a competition for detecting distracted drivers. There would be a picture of a driver, and someone would be looking and paying attention, and someone would be drinking a soda or talking on the cell phone. And you had to write code that would create the ML model on a GPU and try to figure out if that person's distracted. And companies use Kaggle to kind of create AI for their companies, but people like me that maybe aren't experts or weren't experts can now go to Kaggle and ask this community, hey, I'm trying to do this. How do I get over this problem? And the community helps guide you. So it's a great resource. TensorFlow, we talked about a little bit. It's an open source ML framework that anyone could use on-prem or on Google Cloud. And it works on CPUs, GPUs, TPUs, you name it. And another new project was called Kubeflow. This is TensorFlow, in essence, right, on Kubernetes clusters. And it's open source. So you can run it on-prem, you can run it on Google Cloud, or wherever you want. It's a brand new project backed by Google. So all together, right, from the GPU up, machine learning in Google Cloud, because of the data services and the high-end services, we think we're really a great partner. We want to work with you on this. So let's switch contexts. Let's look at another problem. On-premise deployments. They take time. Maybe today you have an existing cluster of servers with GPU workloads, or you're considering, hey, for my new project, do I want to go do it on-prem or use the cloud? Well, there's a lot of problems on this sheet. Right? Ordering the stuff, securing it, installing the pieces, finding co-location, and you could do all that and it might be the right choice for you. Alternatively, you could use Google Cloud. And I'll just talk a little bit about the benefits of using GPU compute on Google Cloud. First is the infrastructure. We've been doing this a long time, right? Building servers, data centers, innovating on power and cooling. And by choosing Google Cloud, you get to take the advantage of using that infrastructure. Large-scale compute, some of the biggest networks, fiber optic backbone, great data center networks, high-end security, high-performance storage. Fast provisioning. I showed you a demo earlier, right, where you can create a cluster, put in one VM, change the number to 1,000, and a few minutes later, there you go, supercomputer. Security is built in. Before Google launched Cloud, we've always been cared about security and privacy and user trust. And the cloud has been lucky to adopt a lot of the same technology we use to protect Google's other services. So it's too much to list here, but we feel that we are a security leader in cloud. And by choosing Google Cloud for your GPU workload, you get that built in. And that lower capital, right? right? You don't have to go spend 250 million on a HPC cluster. Just spin up some capacity and run your workloads. Let's get a little technical, right? Bare metal performance on GPUs. The VM is virtualized, but the GPUs are through PCIe pass-through mode. And what that means is the VM has raw access to the PCI hardware bus, and you have bare metal performance for your GPU accelerator. That applies for all of our models, the K80, V100, and P100. Another piece that I really like about Google Cloud is the flexibility and customization. You're not locked into a strict ratio of I want a small amount of CPU, memory, and GPU, or I have to get a big amount of all of those things, and you just pick in sizes. But instead, you can create a custom VM shape for you. What amount of CPU do you need for your exact workload? How much host memory? What type of GPU, K80, P100, V100? How many GPUs? And what kind of storage? Network spinning disk, network SSD, or in-server SSD. And that flexibility, it gives you super high performance if you want it, or lower cost if that's more preferred. But what normal customers do is they find the right balance. What actually do they need for their workload? And they can eliminate the infrastructure that they don't need and just save money. Per second billing, right? This is great because you only get paid for the exact seconds that you use the infrastructure. We also have something called sustained usage discounts, which is if you just use it for a long period of time, we automatically deduct up to 30% of your bill. And then there's the benefits of Google Cloud. It's an end-to-end stack, huge data, managed services, function as a service, containers, and use GPUs any way you want. So here's our portfolio. I like to think of it as small, medium, and large GPU, right? They vary between performance and price. And K80 is the workhorse. It's 3 generations old. It's also the lowest price and the lowest performance, but it's still much faster than CPUs. It has 12 gigs of memory. It's in many different locations. You can get between 1 and 8 of those in a single VM. 1 generation newer, the Pascal P100. It's great for compute and visualization. It has more memory, 16 gigabytes. And it comes with 1, 2, or 4 GPUs per VM and up to 96 vCPUs or 624 system memory. And the brand new GPU that we just launched with our team, the Volta V100, and this thing literally is a supercomputer in a single VM. You can get up to 8 of these. They're SMX3 chipset. It's the V100, and they come with special NVLink GPU to GPU communication for ultra high performance. And this GPU is specifically great for ML workloads due to its mixed precision. It's not just floating point 64 precision like the others. It also has this mixed floating point 1632 precision that ML really speeds on. So let's look at another problem. Maybe not on-prem, but what if I use a different cloud, right? And how could I save money compared to that other cloud for my GPU workload? Well, I think the best way to show you this is just another demo. So let's go back to the Google Cloud Console and show you what to do with this. So here I am at the Google Cloud Console. I'm going to go away from instance groups and just go right to VM instances. I'm going to create an instance. And let's call this, right, since I'm a New York Rangers hockey fan, let's say let's go Rangers GPU 1. We'll pick a location. Iowa seems fine, US Central 1F. And we'll go to the Customize field. Now, maybe in other cloud providers, what you have is your CPU and your memory, and your GPU will scale linearly. If you want 1 P100 GPU, let's say, you're going to have cores and memory that goes along with that. No option otherwise. Or if you want 4 P100s with another provider, you'll have to get the cores and the memory that go along with that. And because of that, your price per month is going to increase. This is showing you $4,455 per month, right, for this. So the first way to save money is we get something called sustained usage discount. So just by using us for a long period of time for maybe a workload that keeps going and going, not just for one VM, but think of it as for the infrastructure. if you use a GPU or a VM for a while, we just automatically give you discounts, right? Up to 30% for that month, right? It's this amazing saving. You don't have to do a contract, just save right away. So that's one option. Another way to save money on GPU compute is the customization. Well, let's say I don't need 62 cores with my 4 GPUs, because maybe my workload does all the pre-processing elsewhere. So let's just bring back down the number of cores. And for host memory, well, we only use the GPU memory, right? That's faster, it's quicker. We don't need a lot of host memory, so let's bring that down. So just by sliding this down, because maybe your application doesn't need it, we saved even more money. We took it from roughly 4,300 to 3,100. How about another way? Let's give you another option to save money on Google Cloud. So we have something called preemptible VMs. And if I just go down here, click on Management, there's an option, do you want a preemptible or not? If I say yes, now I'll notice I just saved another $1,000. And what a preemptible VM is, Google spare capacity that we might not be able to sell elsewhere. If you're willing to use it with certain limitations, you could save more money. So there are a wide range of areas in how you could save on GPU instances. So let's switch back and tell you a little bit more about cloud GPUs. So let's double click on preemptible GPUs. I kind of hinted at them just now. And what they are, it's a win-win for everybody. Google Cloud might have a little extra GPU capacity. And what we do is we expose them to you through preemptible GPUs. Now there's a limitation, right? The limitation is the VM itself can only last for up to 24 hours. And we might have to take that VM away from you if someone else needs it. But in exchange for that, the CPU and memory will be 80% off, and the GPUs will be 50% off. That's just a clear way to win-win. So if you have a batch workload, like a big training job, and you want to save some money, go ahead and create a managed instance group. Say you want 1,000 VMs with V100 GPUs. And if we have the capacity, you'll get it. And write your code, let's say TensorFlow code, to do automatic checkpointing, where as it's doing the work, it saves the work, so that if the VM comes back online once we have capacity, it just takes over and picks back up. So if you're willing to automate some of your work, you could save some money through preemptible GPUs. So what about it being hard to use GPUs? Well, I guess it's harder than using CPUs. It's hard in the sense where you're going to write some code, or you download an application. And in the code sense, maybe you have to write some new TensorFlow code to say, don't use CPU, use GPU. And TensorFlow takes care of the rest. Or if you have an HPC software, just get it that it's GPU enabled and it will work right out of the box. But what about Google Cloud? What do we do to make it easier? So first thing, we integrate GPUs across the stack of services. So far, I've showed you Compute Engine, about how getting VMs with GPUs is quick and easy. But it's also integrated with Container Engine. Go ahead and get your cluster of container-enabled Kubernetes engine machines with GPUs and run your Docker or container workloads through there. Cloud Machine Learning Engine, right? The managed service for training and inference machine learning, that's also integrated with GPUs. So you don't have to deal with the infrastructure. You don't have to deal with the complexities of building from source TensorFlow and things like that. You just want to run your job. So just go ahead and work in code. Or Dataproc, right? Hadoop and Spark clusters as a service also give you VMs and infrastructure with GPUs, and you don't have to worry about the complexities of managing that. And then the fifth service we've integrated GPUs is Zynq. Zynq is our cloud video broadcasting service with a wide range of things as far as transcoding or rendering, and it's powered, if you want, by GPUs. So let's look at another problem out there. Let's say your workload really demands the highest performance. And then you say, I could run CPUs, I could run K80. Well, Google has you covered there too. We just launched the Tesla V100 GPU. This is the latest GPU from NVIDIA. It has up to a petaflop of performance in a single VM, right? And that petaflop of performance in one VM comes from 8 GPUs and with mixed precision. And this mixed precision means when you're doing a math that's maybe not super, super accurate. And engineering simulations need that, but machine learning workloads don't. So it's great for that. V100s also come with NVLink. And what that means is we have a special hardware board where our 8 GPUs are connected together. And on that hardware board, we use NVLink 2.0 technology that gives 300 gigabytes per second of bandwidth between these GPUs. So in a way, it kind of creates a system where it's such high performance between these GPUs. You could think of a collection of GPUs as one, right? You could use more GPU memory for fast ML and HPC workloads. You could transfer data between these GPUs really quickly. And you'll notice that if you just scale out by saying, give me 1,000 VMs with 1 GPU each, that definitely gets you done faster. But as you go, please give me 1 VM with NVLink, high-speed network with multiple GPUs, the benefits there are even better. We've noticed that up to 40% faster performance just for your deep learning, machine learning, or HPC workloads just by turning on NVLink on the V100. So it's a super fast, super quick GPU, and we just launched it. Try it out. So it's not just about GPUs, right? We want you to pick Google Cloud because we want you to see us as the leaders in infrastructure. We were very early with Skylake CPUs on Google Cloud that literally work with almost any workload imaginable, right? Web apps, databases. They don't do great on visualization, but they're not meant to. So then if you want to get a little bit more specific, but still generic, use GPUs, machine learning, HPC, video transcoding, movie rendering, visualization. They speed up all of those workloads. And then we also have the TPU, a special chip just for machine learning workloads. TensorFlow, the library for machine learning, that's open sourced, works across all of those. So we talked a lot about GPUs and the benefits of Google Cloud. Let's just briefly talk about a couple of customers that use cloud GPUs. The first one is Schlumberger. Schlumberger is one of the leading oil and gas services company. And as this picture shows, one of the services they do is they have these sensor units floating in the ocean. And they send a whole bunch of signals down to the ground. And they get a lot of data, sonar, or radar, a bunch of things. And they just collect that data and they ship it to Google Cloud. Google Cloud, they have a cluster of infrastructure with NVIDIA GPUs, and they process that data. And the end result of processing that data and doing lots and lots of math is they're able to create a map. And that map will show them and their customers, right, how deep the ocean is, where might there be oil, where might there be sand and rock, and how would you get to it, right? And those HPC clusters with on-demand provisioning versus on-premise high capital expenditures was one of the reasons that drove them to Google Cloud, in addition to our security, our reliability, and our partnership with AI services moving forward. Let's look at one more, Shazam. So I'm really, really bad at music trivia. When I go camping with my wife and friends, right, we'll put the iPod or iPad up, we'll shuffle some songs, and my wife will just dominate me in this game. So I love Shazam, right? Shazam's an app where if you hear a song on the radio and you don't know what it is, or at the mall, you pull the app out, you hit a button, and it listens to the song, and it tells you very quickly what the name and the artist is, and lets you listen to it and things like that. And what they do on Google Cloud is they do a lot of data processing, right, with GPUs, and to make those really quick predictions of, hey, I heard this song, it's probably this song, or it is this song, right? They load that information in databases, right, on GPUs to give very quick inference workload results. So in short, 99 problems, but a cloud GPU ain't one. I hope you get started with cloud GPU soon, right? If you're new to Google Cloud, you could sign up, get a free credit, $300, and sign yourself up for some GPUs. There's a couple of links here. Then the documentation will show you how to create a GPU with a VM. And then there's also information about Preemptible. Now we're going to take a little break. We're going to find what questions might be online and come back with those answers. Be right back. Great, welcome back. So on the list here, we have some questions, and we'll just go through them one at a time. So the first question, what's on the roadmap in terms of new infrastructure hardware on Google Cloud? Well, it's a great question. In general, it's going to be what the customers want, right? NVIDIA keeps releasing new GPUs. We just launched the V100. They made some announcements of what might come next. There's always interest on those. So as they launch new high-end GPUs, we'll probably be bringing those in. And also, just like the cloud TPU, right? We focus on what workloads are out there and what other infrastructure and hardware might we continue to bring in. So as customers demand faster, higher price performance ratios for infrastructure, we'll look at new hardware accelerators. But just like GCE, it's not just about those hardware accelerators. We'll also look at things like what kind of a CPU, memory, disk, network. And you can think of Google always pushing forward on all of those. Second question, what type of workloads are a good fit for the V100 GPU? Really, there's two. One is machine learning, right? Because of the mixed precision support and the NVLink connections between the GPUs, this is a very optimal machine learning GPU. A lot of our customers are using these in large scale to do machine learning training, starting to do some inference workloads with TensorRT, right? Great for ML, but also just really good for high demanding HPC workloads, right? If you really want your results done quickly and fast, right? It's a great GPU for that as well. So next question, can you have both preemptible and dedicated VMs in the same cluster? Another good question. So you can, yes, in both GCE and Kubernetes engine. So on GCE, there's two types of instance groups, a managed instance group and an unmanaged. In the managed instance group, we do things like auto-scaling and rolling back code. And with a managed instance group, we want the same type of VM, the same shape, and so on and so forth. So for that, right, we say it has to be the same kind of template. But in an unmanaged instance group, right there, you can put whatever VMs you want into a group. It could be dedicated, it could be preemptible, and it could kind of scale as you need. Then the third way is you could just have two instance groups, right? You could have a managed instance group, both managed instance group, one dedicated, one preemptible, and you could have one capacity change over time with availability and the other one always there. Right? So that's what a lot of our customers do on GCE. On Kubernetes engine, you have something similar. Right? Kubernetes engine has the notion of node pools, right? And you could have one pool of nodes be preemptible and another node pool being dedicated, right? And you could scale that side differently as well. So both of them have an option to do it, yes. Let's look at the next question. What would I need to do to use preemptible GPUs at large scales on GCE? So with GCE, the demo I just showed you, that's one way, right? A managed instance group, you create a template, and you scale up the instance group to the size you want. In order to get to that, there are a couple things you have to do first. You have to have an account, and then you need what's called quota, right? Quota is a way to make sure that the customers that are using capacity are the ones that are the right customers to use so in some way, right? So at first, you'll have a small amount of quota, and if you really want to run a cluster of 100 GPUs or 1,000 or even more, just go online, go to the quota system, and say, this is the max I want to run, make a submission, and we'll get back to you shortly with what you're allowed to go up to. So those two things, managed instance group and quota, will get you that scale. Or same thing with Kubernetes, right? Get a Kubernetes cluster or get some quota, and then you can get up and running. Next question, when should I look at TPUs or GPUs for ML workloads? That's another good question. I think both TPUs and GPUs are going to be a great fit for ML, right? Both GPUs are going to be a little bit more generic, kind of work good for all workloads, all libraries, TensorFlow, PyTorch, Skylarn, Keras, you name it, it's going to work. And it's going to work for inference, it's going to work for training. TPUs, they're going to be very specific to the TensorFlow for now library. And it's also good for very specific models. And it's going to be really good from a price performance perspective for those models it works. So at Google Cloud, you could use either. We hope you do use the one you want. And we'll keep launching new generations, and for better price performance, we'll keep launching new features to make it easier and easier to support ML workloads on GCE. And last question, are there any plans to offer AMD GPUs on Google Cloud? At this time, we just do NVIDIA GPUs, but we're talking to some customers that have expressed interest. So if you have interest for AMD, just reach out